How do frogs jump so high and so far? You probably think it's all about those powerful hind legs, and you're right, they're really important. But those legs alone aren't enough to send these little amphibians flying through the air multiple times their body length. There are some other key factors at play here, some of which will... So why can frogs jump so high and far? We'll tell you right after. As we mentioned, one main reason frogs can jump impressive distances is because of their extremely long and strong hind legs. In most animals, including humans, the legs are roughly the same length, but frogs' back legs are more than twice as long as their body length. They're also much wider than their front legs, giving them better leverage to generate force when they jump. These leg muscles are highly developed, especially when compared to the rest of their body, and they're able to contract and relax very quickly. Think of those leg muscles like a bunch of tiny compressed springs. When they're relaxed, they're ready to release all that stored energy in an instant. Now, frogs' legs have several advantages over our own. One thing they have in common, though, is that both frog and human legs are made up of bones, tendons, and muscles. Tendons connect muscles to bones and are a major factor in how frogs can jump so far. But first, let's look at those frog muscles. The muscles in their hind legs are what you might call slow-twitch fibers. Slow-twitch muscle fibers contract more slowly than fast-twitch fibers, but they can sustain contractions for long periods of time without getting fatigued. This is just what you want for a jumping muscle, since the power of each leap depends on how long the muscle can remain contracted. But even with super strong leg muscles, frogs wouldn't be able to jump very far if they couldn't store and release the energy generated by those muscles quickly. That's where the elastic tendons come in. Tendons are similar to ligaments, which connect bone to bone, except they attach muscle to bone. They're made of tough, fibrous tissue that can stretch and recoil. Now imagine you have a rubber band stretched around a box. If you let go of the rubber band, it'll snap back and push the box. The further you pull the rubber band away from the box before releasing it, the harder the box will be pushed. Similarly, when a frog contracts its leg muscles, the tendons in its legs stretch, kind of like that rubber band. Once the muscle is relaxed, the tendon recoils, releasing the stored energy and launching the frog into the air. So strong leg muscles plus elastic tendons equals powerful jumps. But there are two other important factors that allow frogs to jump so far. Another thing frogs have in common with us humans is that they have hollow bones. Hollow bones are lighter than solid bones of the same size, which helps reduce the resistance the frog experiences while jumping. Solid bones have a greater density, meaning they weigh more than hollow bones of the same size. If you compare the skeleton of a frog to that of a mouse or squirrel, you'll see that a frog's bones are much lighter and less dense. That's because frogs spend a lot of time in water, and being buoyant is helpful for floating. If frog bones were as heavy as a mammal's, they would sink in water and not be able to move around very well. So frogs have evolved to have bones that are lightweight, yet still provide support and structure. When it comes time to jump, a frog's lightweight skeleton gives it another advantage. Since the overall mass of the frog is reduced, it doesn't take as much force to get it airborne. A smaller mass means less inertia, which is the tendency of an object to resist changes in motion. So once the frog's muscles start contracting to initiate the jump, the lightweight bones help get the frog's body moving quickly. Another adaptation that allows frogs to jump incredible distances is their stretched-out body shape. When a frog prepares to jump, it arches its back and extends its limbs, which elongates its body. When it jumps, this posture acts like a pogo stick, maximizing the distance traveled with each leap. The further the frog extends itself before jumping, the higher it can jump. Additionally, the shape of the frog's foot helps it grip the surface it's jumping off of while also providing traction when it lands. The bottom of the foot has a rough, bumpy texture, and the bumps are actually pointed backwards, which helps anchor the foot to the ground. Now there are some exceptions. Webbed feet allow frogs to move through water more easily, but they aren't as good at gripping onto land. But when frogs are out of water, they can actually retract the webbing between their toes to give themselves more traction. So now you know that a frog's unique skeletal structure, along with their super powerful legs and tendons, helps them jump so high and far. But why would frogs need to jump great distances in the first place? Well, there are several reasons. One reason frogs jump far is to escape predators. Frogs are often targeted by snakes, birds, and mammals like foxes and turtles. Being able to jump far helps frogs evade these predators. Even if a predator manages to grab a frog, many frogs can secrete a toxin from their skin that'll make the predator regurgitate them. It's not pleasant, but it happens. So being able to hop away from danger is an effective defense mechanism. Frogs also use their jumping abilities to catch food. Most frogs are carnivorous and eat insects and other small animals. Many frogs wait for their prey to crawl pretty close before striking. Having such long legs helps them snap their mouths shut quickly, catching the unsuspecting insect or other small critter. Long legs also help frogs travel. Some frogs live in forests and use their jumps to navigate the terrain. Others live in or near ponds and swamps and use their jumping skills to move about in the water or on land. While some frogs are great at climbing trees, others prefer hopping around on the forest floor or floating on top of the water. No matter where they live, having long legs makes traveling easier. Some frogs can jump farther than their own body length. Take the Panamanian golden frog, for example. This brightly colored amphibian can jump up to 20 times its body length. If we did that, it would be like someone who is 1.7 meters tall jumping over 34 meters in a single leap. That's about the length of 3 basketball courts lined up end to end. Frogs are incredibly diverse. There are more than 7,000 species of frogs living today. They range in size from the tiny Pediphrene amuensis, which is only about the size of a housefly, to the gigantic Goliath frog, which can grow to be almost a meter long and weigh over 3 kilograms. Frogs live on every continent except Antarctica, and they've adapted to live in many different habitats. Some frogs are true acrobats, leaping deftly between branches. Others are expert swimmers, propelling themselves through the water with powerful strokes of their webbed feet. Still, others are burrowers, using their strong forelegs to dig through the soil. So whether they're leaping through the air or digging through the dirt, frogs are perfectly adapted for their way of life. Now you know a few reasons why frogs can jump so high and far. Their super long and powerful back legs, elastic tendons, lightweight hollow bones, and streamlined body shape all contribute to their amazing jumping abilities. They use their jumps to escape from predators, find food, travel through their environment, and much more. So next time you see a frog, remember that it's not just a small, slimy creature that lives in ponds. It's a master jumper that's perfectly adapted for its way of life. If you learned something new today, make sure to like this video. Don't forget to keep on thinking. Thank you.